Now these are nothing but complementary signals. Let's see if this complementary signals has any drawbacks. Yes, it does. The first problem is clock skew. Now what is a clock skew basically? Suppose this is your external clock and this is your chip where the clock needs to go. Ideally, this external clock goes to the chip and there is a clock generator circuit inside the chip which will generate the clock and pass it to all the different blocks. Now what's going to happen is, this I have covered in detail, or I'll be covering in detail in the entire module ahead. Right now for the basic understanding, let's say that this is my clock and I want phi and phi bar from this clock. So what I've done is I've just connected two inverters, correct? And from the output of two inverters I get my phi, and output of one inverter I get my phi bar. Now I'm presuming that both this phi and phi bar are going to drive equal load. Equal load means same amount of capacitance they are going to drive. If that's the case, and these are two inverters, so to produce phi I have two inverters, to produce phi bar I have one inverter. Obviously presuming that the delay of one inverter is 2 nanoseconds, and this will be 4 nanoseconds, this will be 2 nanoseconds. So phi and phi bar, which needs to be exactly complementary to each other, which I have drawn here, because this is 0, this is phi and this is phi bar. Don't get confused, this is high, this is also high. Technically they both should be exactly complementary to each other, but because of this small variation, which is nothing but skew, phi and phi bar will differ in the phase slightly. Look here. Basically what happens due to clock skew is the following. Suppose this is your phi. It's not very evident here, or it's not clearly seen here. This is your phi and this is your phi bar, correct? Phi bar and phi. Let's see, we'll see it from here. This is garbage. Technically when this is high, this has to be low, correct? But because of the delay, some delay, this will go low after some point of time and it will again go high after some point of time. Basically this difference, this small difference where it has to be exact complementary, it's not because of clock skew. In this case, this is phi and phi bar. Technically phi is delayed, so we can easily say this is phi bar and this is phi. But what you need to understand is nothing but the concept of clock skew, which will cause a difference in the phase between your phi and phi bar signal, which is not a good idea because you want it to be exactly complementary. So that's one of the drawbacks. Let's see if there are any other drawbacks. So other drawback is nothing but the problem of charge leakage, which again we have covered extensively in this entire module. In brief, if you want to understand, when phi is equal to 1, this is on, so A is coming here. Remember there is a capacitance present here. At that point of time this is off. Let's assume that A was 1 or VDD, so there was VDD at the capacitor here. Now when phi goes to 0, this becomes off, this is on. When this is off, it technically has to hold this value of VDD at this node. But because of this transistor being off and there are reverse leakage currents, like there are a lot of reverse leakage currents which flow, due to this charge leakage problem, this node might lose out on its value, and hence what will happen is we might get a wrong output. This problem of charge leakage we have discussed extensively, and we use refresh mechanism to avoid this problem. But this is again one of the problems in the logic cascade when you use your phi and phi bar signal without a feedback loop. We have also solved this problem by adding a feedback loop in the clips, but this is one of the problems which you need to understand. Let's see if there are any other problems here. There is a race condition as well. Till now we have assumed that phi and phi bar as idle signals, which means a square waveform is what we had drawn. But technically this is not to be the case. Every signal has a finite rise time and a finite fall time. If that's the case, look here, this is the rise time and this is the fall time, which means at some point of time when the input has crossed some value, this phi would be interpreted as logic high and this phi would be interpreted as logic low at the same time. That means some point of time in between, this will also be on, this will also be on, and this is on means it is taking a new input which it is processing. This is also on. It might take the previous value of the output, or some problem might happen. If you have not followed this, what's going to happen is this. Just pay attention. Because you want both of them to be exact complementary, when one functions, the other does not function. When this is not functioning, this has to function in order to get you a correct output. but because they both have finite rise time and fall time in real time scenario, both would be on at some point of time, which is shown here. And if that happens, you will get a wrong output because you have designed your system in such a way that only one has to produce an output at a specific time. So again, this is a problem, race condition.